types of networks. Okay, we'll see, right, why industry is moving, why wireless industry is moving forward. Okay, so what are the fundamental principle operation, right? We need to understand what is the fundamental principle of operation of all the mobile generations. Okay, so I'll start from the 1G. Okay, so 1G, what is the fundamental operation of 1G? See, otherwise, why, how technology has moved from here to here, from here to here, from here to here, from 3G to 4G, still why technology is moving. So I'm not going to teach, I'm not going to discuss applications. I'm going to teach you the technical part of it. Okay, what was the drawback and what is the fundamental operation, right? Why moved industry to here, 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 here. Okay, anyway, you are all into telecom and working. Okay, so but let me go through in my way so to understand easily. Okay, so technically I can say, so here it is base station and more number of mobiles, more number of mobiles. I used to write mobiles like this. Okay, so more number of mobiles, even, right, hundreds of mobiles, how they are communicating with the base station. So what is the underlying principle? Can anyone tell me? So here it is only one antenna, right? But so many devices can connect. And what is the uh, underlying principle or technologies? Hello? Can anyone tell me?
Is that TDD FDD techniques?
That is okay. TDD, FDD is what? FDD, TDD is a frequency. Okay. TDD, FDD tells you, right, only FDD tells you, right, whether you have uplink frequency separately, downlink frequency separately. TDD tells you only one frequency, right, can be used for uplink and downlink. Apart from this, technology, how these people are able to, how hundreds of mobile, how hundreds of mobile are able to communicate.
Based on bandwidth, like one you connect to base station that may be reserved as a time slot, like in the 2G it is in the time slot, like in the 4G it is in like slot wise, symbol wise.
Hmm. Okay, somewhat is it is fine. There is a techniques called multiple access technique. Mul multiple multiple access techniques. So not only here, any wireless communication. For example, right, even in Wi-Fi is there, Bluetooth is there. For example, wired communication is there, even wired communication is there. So how multiple means multiple devices are able to communicate by using the multiple access techniques, means multiple people are able to, or multiple devices are able to communicate with the base station based on the multiple access only. Okay, so what kind of multiple access techniques used in the 1G? So frequency division multiple access. Okay. So here we have two flavors. One is the GSM, another one is the CDMA. Okay. So here it is, means the channel allocation is based on the frequency here. Channel allocation is based on the TDMA here. Plus anyway, FDMA is also there. Then channel allocation is done based on the code. Channel allocation is based on the code, but wider bandwidth. Okay, wider bandwidth. Okay, so then 4G. by using OFDMA and SCFDMA. Okay, OFDMA and SCFDMA, whereas here it is, right, again OFDMA and SCFDMA. What are all this? Right, without this, right, there is no 1G, there is no 2G, there is no 3G, there is no 4G, there is no 5G, and next generation NG. Right, some of the right next generations are going to right use the NOVA, but it is not yet finalized, right, till OFDMA and SCFDMA. Not only right OFDMA is using in many systems like Wi-Fi. Here also Wi-Fi 5, Wi-Fi 6, even Wi-Fi also generations are there. In Wi-Fi also a generation Wi-Fi 6, 5, Wi-Fi 6, now 7 is running. So here also OFDMA is using. So means like how this is the core technology, right? Bandwidth is there, that's okay. Bandwidth is there for 1G, 2G, 3G, that's okay. But how mobiles are using this bandwidth to access? Well, that is important. Okay. So without understanding means like how technology is moving from here to here, here to here, here to here, here to here, then it is still going on. What is the fundamental principle? What are the drawbacks? What are the advantages? This we will see one by one. Okay, right. So let me go through. Let me go to the path. Okay, let me go through the fundamental path of the technologies. Okay, IEEE. Okay, just give me a minute. All right, just a minute. Right. So this is the actual how mobile communication and other standards are moving. Okay, so we have three standards. One is initially we have three standards. Now we have two standards. Okay, so IEEE standard. So these are IEEE standard 802, 802.11a, 11b, 11g, and so on. These are all, you can say, Wi-Fi, Bluetooth, Bluetooth, wireless sensor network. Okay, so these are the models for this kind of technology. So of course both are wireless but this is called IEEE as per the IEEE standard. The fundamental technology here it is CSMA CD, CSMA CA. Okay, uh, right, technology goes like that. So means collision avoidance technology, collision detection technology, right? So here it is European standard. First European people have started the GSM. Okay, so by that time American people started IS-54, right? This is the TDMA, generally North American TDMA, and this is GSM. Of course, Americans only started 1G uh, with the AMPS, companies, the AMPS, Advanced Phone Mobile Services. They brought the 1G service, 1G services in US. Later on, European people has developed GSM. Then these people has developed TDMA. Then GSM evolved into GPRS. Then Edge, WCDMA. So that is 3G. Then 3G plus HSPA, High Speed Packet Access System, high speed packet, high speed downlink packet access system, high speed uplink packet access system. Then this is somewhere 3.75G, you can say, right? And here it is the LTE is the de facto standards for the 4G. And this is still, right, evolving like this, 4G advanced, right? So this is, right, going like this. Then people thought, by that time, North American people started IS 95, where this is exactly the CDMA. Okay, CDMA, then IS 136. Then people thought that why we should have two different paths. Why? Because uh, I don't know whether you used CDMA or not, but people were confusing. Like 20 years back or 15 years back, um, people were in confusion to use CDMA or GSM. But before, CDMA is a superior technology and which is the base for all 3G, 4G, 5G technologies. But before installing the CDMA, people were comfortable with the GSM. Okay. So, right, people are comfortable with the GSM, right, not adapted to the CDMA because much before GSM already installed everywhere available in the world. And people were, some people were adapted and there was a confusion which one to use. Then people, this right technologists and thought that why we should have it two separate. Then they started 3GPP organization, okay, which we are seeing now, and this organization is responsible to right finalize the technology specifications, right? So this evolved like CDMA 2001X EVDO, then it got stopped, right, as this merged, right, merged in this path, then LTE advanced, right, somewhere release 15, right, 5G, NSA, right, then, right, ESA, and still going on. This path is going on, which means these two merged at some point of time before starting the 3G. So then this means after 2G, 2G means like is a closed architecture, means technology has developed. There is no uh, right, there is no chance to implement if any new algorithms are there. So that's why they named LTE long-term evolution, means the technology is open. Means like they kept technologies open. Whoever wanted to build a better algorithms, they can be implemented. So that's why it is named as a long term. The technology is going to evolve long time. Okay. So 5G is an extension of LTE only. Okay. I hope you got it right. So then this 3GPP organization, right after this 3GPP, right, and it is even from 3G itself defining the specifications, right? So you might be heard 3GPP. 3GPP is an organization, right? 3GPP is an organization which is finalizing the technology, and this nowadays right here, this 3GPP is a organization with the government bodies, right? Organization with the technologists and scientists, uh, universities, right? IEEE is a part of it, as well as companies like Jio, AT&T, right? Which funding, these companies are funding this organization. So definitely there is a standard body should be there, right? For example, if you are purchasing any USB cable, right? Definitely USB cable, right, with a particular width and length. Okay. Right means like along with the some standard protocol. This is built on standard protocol, right? If you wanted to build a USB with your own specifications, nobody stops you. But when it comes to the public domain, right? So when public purchasing, they should use it. So that's why the standards are very important. Okay, people are purchasing, people are building, even uh, Japan has built PCS communication and other communication. They means like those are right in their country only, right? They have means like that is possible. Out of 3GPP also we can build, but right, who purchases? If I purchase a USB cable with a different length, right? How, where I can use it? So that's why standard body. So this is the standard body, right? Which defines the technology, and how means like hardware means like defines the hardware specific, not complete hardware specification, but when it comes to the RF and frequencies, right? And plus complete software specifications, right? All the companies must follow, right? To verify whether a company followed the 3GPP specifications or not, third party verification will be there, right, on base station as well as mobiles. Okay, third party verification like GCF certification, PTCRB certification. Without these certifications, right, either mobile or base station cannot be right released into the market. I hope you got it right. Hello.
Yes,
Yes,
sir.
Right. So now these are the right fundamental differences, right? From 1G is purely analog, right? Analog. So which means right, if I can tune to a particular channel frequency, I can hear what people are talking to each other, right? And what kind of communication is going on. So, but from GSM 2G, from 2G, right, it is a digital, completely digital. Okay, completely digital, where we can manipulate the data to means like uh, protection from the right tuning to particular channel frequency, right? It is, of course, I cannot say it cannot be done, but little hard to catch any channel information. Okay, I can say that it is not impossible, but it is hard to catch the anyone's channel. So that is the beautiness of digital, because I can play around the zeros and ones. Digital means what? Zeros and ones, right? I can play. I can play with zeros and ones. Okay, so you can see these are the typical data rates, right? GSM 9.6, IS 95, right? This is called a CDMA. Definitely, in terms of security, in terms of capacity, in terms of data rate, CDMA is superior to GSM. But unfortunately, when CDMA when CDMA announced, right, GSM already there and people are using comfortably. So that's why not people not adapted it. Okay, then GPRS, then CDMA 2000, which is released in 2000, right? 3G, then HSPA, DPA, release 15. From this, you can see release 15. So this is 3GPP. Okay, release 5. Then CDMA 2000, 1X EVDO, HSPA plus, release 6. Right from another technology was there like Wi-Fi, WiMAX, which is microwave frequencies, and most of the times it needs LOS, right? For all the communication, LOS is required. So, right, when it comes to mobile communication, right, mobile means like users used to move here and there. LOS is not possible. So that's why it was not that much of popular, but LTE became very popular. Then LTE advanced, now 5G. Okay, 5G, the expectation is, of course, once again, 5G is not only for, these are all mobile communication. Okay, but 5G is a not only mobile communication, but it is for different communication. When it comes to mobile communication, 20 Gbps in downlink, 10 Gbps uplink. Okay, so these are the fundamentals of, means fundamental organizations, how the technology has evolved, and fundamental data rates. Okay, so let me go through why people moved from 1G to 2G, 2G to 3G. I was talking about, right? The fundamental technology is a FDMA here. So let me go through, right? So this is FDMA. So what do you mean by FDMA? This is frequency division multiple access. Multiple access. So what do you mean by this? Frequency division multiple access. Definitely we know that frequency is costly. Okay, frequency costly, right? So companies purchase the frequency from the government in auction, right? With the 5G spectrum auctioning, Indian government got 1 lakh crores. Okay, still some part of the spectrum only sold, right? Next time they will auction one more time, one more time, one more time. You can see the how costly it is. Frequency is costly, right? We should use, means like operators should use very carefully. Okay, so frequency division multiple access means channel, right? Channel allocation in terms of frequency. Channel allocation in terms of frequency domain. Okay, frequency domain. So let me, so government ITU, right? ITU, International Telecommunication, as assigned, right? AMPS has brought this technology, advanced mobile phone services. So this, to this company, ITU has assigned 25 megahertz of frequency for total 1G services. 1G services. Okay. So we have two things here. One is the terminology, right? One is frequency, right? The bandwidth, as well as channel bandwidth. Okay. Frequency, bandwidth, channel bandwidth. Okay. Sometimes you may see the carrier bandwidth. This can also be called carrier bandwidth. Okay. Channel bandwidth, carrier bandwidth. So initially you should understand. Okay. So can anyone tell me what is the FM frequency? Means FM radio frequencies.
In 90s range.
92, I think 120.
Yeah, go ahead. What is the FM frequency range? Red FM or Radio Mirch?
The range of 90.
It's like in the
Okay,
mega,
right.
like
Somewhere around 80 megahertz to, right? 80 megahertz to maybe 110 megahertz, right? There is something 93.5 FM, right? 105.5 FM. I am not exact, but this. So what do you mean by this? This is the frequency of operation. This is the frequency of operation. Frequency of operation where the FM station transmits. But what is the human voice frequency? Can anyone tell me what is the human voice frequency?
4 to 20 kilohertz.
Sorry,
4 to 20 kilohertz.
20 kilohertz. 20 kilohertz is higher, man. Right. 3 to 4 kilo.
3 to 4 kilohertz.
3 to 4 kilohertz only. Right.
Yeah, correct.
So when you are talking on your mobile, right, your voice will be, right, for example, many of your voice around 3 kilohertz, but my voice is 4 kilohertz because I am teaching, I am talking a little loudly. Okay, so that it will be around 4 kilohertz, 3 to 4 anywhere, depending on the right talks. So which means which means radio jockey, right? So this is the FM radio station, right? My radio jockey, right, is talking about at 3 to 4 kilohertz, right? But this is operating at let us take 93.5 megahertz. 93.5 megahertz. My radio jockey is talking this, but the station operation is here. Why this difference? So in generally, right, if I can take the range of FM station is right somewhere around 50 kilometers or 52. It depends, right? Operator interest, right? If we can pump more power, it may go somewhere around 70 kilometers also. Okay. Of course, the frequency of operation it goes. Okay. So to transmit the signal, right? 50 kilometers, 30 kilometers, 70 kilometers. Okay. So there is an issue to transmit here. I cannot transmit. I can transmit this. I can transmit without this frequency. I can transmit this, but I need to have a antenna, right? The tower will be at least 2 kilometers, 2 kilometers height. Is it possible to build?
No.
Is it possible to build 2 kilometer, 1 kilometer antenna? No. Right.
No.
Maximum of our cell towers are 120 meters. Right. Initially in 2000, it was 120 meters. Now the cell towers became 38 and pole mounts. Most of you know, right? So 120 meter. So to reduce the antenna height or tower height, there is a need for the modulation. Okay. There is a need for the modulation where modulation applies here. Okay. So which means this will be modulated onto this frequency. Okay. So simply you are transmitting a message. This is right. For example, radio jockey, whatever the radio jockey talks, that is called the message. That message will be transferred by using the megahertz frequency. So which means this will be modulated right onto this so that I can reduce the right tower height. So which means like tower height maybe somewhere around 80 meters. Okay, maybe 90 meters, right? I depends, even 100 meters also. That's up to FM station transmission, whether they wanted to transmit to 50 kilometers or 70 kilometers or 100 kilometers. So if I can increase 80 meters to 100 meters, I can transmit the signal to little more distance. If I can increase the height of the antenna to 120 meters, I can transmit to even 100 kilometers. So that depends on the FM station target till where they wanted to transmit. Okay, so which means there are terms, there are terminology you should understand, right? The frequency of operation. So this is called the frequency. Okay, the frequency is here 93 point. So let me write separately. I hope you got it right, the difference. So now the frequency of operation FM station is 93.5, means like some range. Let us take example. Whereas 1G was right 800 megahertz. Okay, satellite frequencies around right 6 gigahertz. Okay, then 5G is right somewhere even 52 gigahertz. Now this is a satellite communication, right? So 5G, right, the FR2 is 52 gigahertz. Okay, you can see these are all called frequencies, right? These are all called frequencies of operation, right? And also in LTE, we used to say these are all, of course, frequency of operation or carrier frequencies. These are also called frequency, carrier frequency. Carrier frequency is what? So this is carrier here. So this is the message. Here it is the carrier, right? Which, right? So this is your message. This is the carrier. This carrier is taking your message to the longer distance. You might have seen that lorries, right? Most of the lorries are written with goods carrier. Correct or not? Goods carrier, which means carries the goods from one place to another place. Goods are here message, and carrier is lorry, which takes the message to public. Okay, so which means either you can call it as a carrier frequency. Sometimes you can say band of frequencies, or band also means in different technologies. Either you can call frequency of operation. Okay, frequency of operation. So these are fundamentals you should understand before getting into the course, right? Otherwise, right, always there is a question, what is, because we used to talk carrier, bandwidth, the right, many times. You should be able to understand the difference. Okay, right? So carrier frequency, band, you can say, or frequency of operation. I hope you got it right.
Yes, sir.
Hello. Right. So bandwidth. So this is, right, usually upper frequency minus lower frequency. Upper frequency minus lower frequency. Okay. Right. What is this upper frequency and lower frequency? Let us take, we have taken example 1G. So what is the upper frequency, right? The band is 800 megahertz. So let us take 1G, right? The band is 800 megahertz, right? GSM 900 megahertz, 3G, right? 1800 megahertz, 1900 megahertz, 4G, 1900 megahertz, 2100 megahertz, 2300 megahertz. Okay, so like this operation. Then what is the bandwidth? I was talking about 25 megahertz right here. This 25 megahertz assigned to the 1G services. So this 25 megahertz right here, upper frequency minus lower frequency, the result will be my 25 megahertz. Okay, that is what frequency, that is what bandwidth, So let me go through, right, what is the bandwidth for 1G services. Okay, so this is, you can see. So right, technically from base station to the mobile, it is DL. Now we are calling UL. But olden days, right? They used to call forward channel, right? Reverse channel. Okay. Reverse channel and forward channel. So my forward channel bandwidth is 894, right? So simply I can say nowadays we are calling it as a downlink frequency. Okay, downlink 894 minus 869. So what is the 869, right? So what is the difference? 25 megahertz, right?
Okay.
Yes.
Right. So what is the UL frequency? So you can see the reverse channel, which is 849 to 824. Again, this is also 25 megahertz. So means this is megahertz. This is megahertz. Whole thing I can call, right? 1G operation was at made around 800 megahertz. Okay. 8 to 900. You can say 8 to 900, but this is called generally 800, around 800 megahertz, 800 to 900 megahertz. Whereas 2G, 900 megahertz band is there. Correct or not? So this is called the bandwidth, right? So this is called the bandwidth. Bandwidth is, right, upper frequency minus lower frequencies, right? You will get the bandwidth. So this bandwidth is assigned to amps, advanced mobile phone services, right? ITU assigned. So totally for 1G, 25 megahertz has assigned. But what is the human voice? What is the human voice frequency? 3 to 4 kilohertz, right? Which is much lesser than the 25 megahertz. Am I correct or not?
Yes.
So that's why to transmit this, we need a channel bandwidth or channel bandwidth. So that's why, right, people what they have done, right, they divided this by the channel bandwidth, and the channel bandwidth, the estimation for this 1G services is, right, 30 kilohertz, right? Each channel bandwidth, right? After after doing the experiments, several experiments, voice transmission, they have decided that 30 kilohertz is enough to carry this. Clear? So 30 kilohertz, then how many channels we should get? Okay, how many channels we get, right? So total 832 channels. 832 channels we get in 25 megahertz of each 30 kilohertz. Means in entire right 1G there was 832 channels. So what do you mean by the channel? What do you mean by the channel? Right, when we installed a tower, one channel is given here. Okay, so which means this assigned with one channel. So means there is a possibility that 832 towers can be installed. Okay, so that is the right. But the problem is here. Okay, so now let me take in term. I hope you are able to follow me, right?
Yes. Yes.
No doubts. So this you should understand this all. Okay. So this is my frequency. This is my time domain. Okay. So what am I calling my frequency domain is having the 25 megahertz bandwidth, right? This is divided into, right, 25 megahertz divided into 30 kilohertz, right? So which means each of my channel is a 30 kilohertz here. So this is my channel with a 30 kilohertz. This is my channel with a 30 kilohertz. Okay, this is the channel with 30 kilohertz. So like this, first channel, second channel, third channel, fourth channel, fifth channel, right, and so on. So that my last channel is 832, right? Which means I can say, and each channel can be given to a tower, right? Which is, so this, let us take first channel, this second channel, the third channel, like this. But here, the disadvantage is, right? So one channel can be used by one user at a time. So for example, let us take in your area, right? If let us take, if this 1G service is installed, 1G base station is installed in your area, okay? In your area, at a time, only one mobile can connect. Only one mobile can connect. If this one mobile wanted to use 24 hours time, right? This is time domain. Let us take this 24 hours. This access is 24 hours. So this is given to user one. This is given to user, means like user two, user three, user four, and so on. Means this is given to 832 users. Means one frequency, one channel per one user. Okay, one channel per one user. Okay, guys, get just a minute. Simply, I can say one channel per one user. Definitely, right? Not a, if thousand, if right, let us take in your area example, 10,000 users has taken connection. Then definitely, if these people wanted to communicate, they used to get the busy, right? Correct or not? Correct or not? You can see the operation look like this. This is my total 25 megahertz bandwidth, right? So human voice 3 kilohertz, right? So that will be modulated onto 30 kilohertz. So means total 832. Entire 1G supports 832 users only. Users only. But if there are 1 lakh people taken connection, is this enough? If 10 lakh people have taken connection, is this helpful? If 1 crore people has taken connection, is this technology useful? Is it useful?
No.
No.
But 1980s, it is okay. 1980s, few people were, at that time, call rate was very costly. Okay, few people have taken, those who are rich people. Okay, rich people have taken connection, but somehow very great technology in 1980s. But if we take and apply nowadays, nothing. Because everybody is having, in 2000, at least hundreds, thousands of people were having. Nowadays, right, crores of people are having. Not at all possible. One channel per one user is not applicable scenarios now or nowadays. Okay, right. So we'll see tomorrow, right? Other factors in 1G along with the other technologies. Fine. For now, I am closing. Okay,
Okay, sir.
right? Right. If no doubts, we can close the class.
And then one question.
Go ahead.
This 30 kilohertz, it is called that carrier spacing, right?
Yes, bandwidth, carrier bandwidth, channel bandwidth.
Channel band means the distance between one channel to another channel, right?
Yes,
That is
no, user based. So this mobile connects with the channel, right?
yeah.
See, for example, city A to city B, you may have one road or you may have multiple roads.
Correct.
So in this case, only one road is there. So one road at a time, one guy can only go. This is the situation.
So
There
in
is
1G,
there
so
is
in
a
one,
road.
so in 1G, there total 832 frequency channel. So further it divides in like 3 or 4 operators.
See, in India, if I installed entire India, right? 832 towers, 832 people. Simple logic.
No, but it cannot be assigned to one operator. No, it can be assigned for
Many
multiple.
operator, that depends. Okay, but amps, it was there only amps. This 832 channels can be assigned to different operators. Correct. Operators, right? Operators may purchase 10 channels, 20 channels, 100 channels. Depends on the capacity. You are correct.
So channel is having itself a frequency, its own
Correct. Correct. Channel is a self-frequency.
frequency.
Correct. Here it is,
So-
my channel is, right? Let us take channel number 30 or channel number 40 at 800 megahertz, I can say. Right?
Yeah.
Right. We'll see tomorrow.
Okay, thank you.
Thank you.
Yeah, we'll see tomorrow.
Thank you, sir.